Thank you everyone for attending this session. Today I'll be talking about the evolving drop zone in Microsoft Fabric, from file triggers to continuous ingestion, different methods and different features to help us to build a drop zone. This is me. I'm a former data platform MVP. I work for Onyx Data and the Tower Software, my company. I'm a trainer with some Microsoft certifications, and I live in Malta. I'm the leader of the Malta Data Platform User Group. You can see on the right side my contacts. It will be a pleasure to stay in touch in social media on LinkedIn, YouTube. I'm always publishing technical content. So the agenda today. Let's start aligning about what's a drop zone. Let's talk about Azure events in Fabric, one lake events in Fabric, and the continuous ingestion. What's a drop zone? This, you may be already familiar with it, is a medallion architecture. We have bronze layer, silver layer, and gold layer. Sometimes this is exactly the medallion architecture. Sometimes we create an additional layer before the bronze layer. We create what is called the drop zone. So drop zone is optional in the architecture. It is usually not even represented as part of the main architecture. The role of each layer is more a guidance. I already saw many implementations of the medallion architecture where we can notice a difference in the way each layer is implemented. So the role of each layer in the architecture is more of a guidance, especially like drop zone and bronze, where the drop zone is even optional. Can we specify a rule set on stone about what it is? No, we can't. It's like a guidance. So, to understand it better, it's interesting to note what we need in relation to these layers, especially the drop zone and the bronze layer. We need an area where the data arrives. This happens especially if we are ingesting some kind of file source. For example, even if we are ingesting from APIs, sometimes we would like to drop the information that that API gave to us in a file format. So we need an area for this data to arrive. So you may be noticing by this explanation that uh, one thing that may sometimes make the drop zone optional is the type of source. Sometimes some types of source may allow you easily to skip the drop zone, and it's an option if you do so. So, an area where the data arrives, the data stays until the processing. So, we're talking about file ingestion. So, we ingest the files, drop the files in this area as storage, and the files stay there until it's processed. Then, when the data is processed, the file is dropped. We process that file and drop that file. Uh, why we drop that file? Of course, it's optional. Of course, there are different ways to implement this. But one reason, one reason for dropping the file when it's processed is the fact that it's easier for an ingestion process to read out the content, the data content in the folder. Read the content in the folder, import it, ingest that content, and drop everything. And then wait for new content to arrive. If we don't drop the file, the ingestion needs to identify what files were already ingested, what files are the new ones that just arrived. making the ingestion process a little bit difficult to develop. So an easy way to work with the ingestion process is to have an area where the file arrives and it stays there until you process it. When you process it, the file is dropped. This is what we can be called as a drop zone. But there is also a need of an area to store the incoming data. What do I mean about the store the incoming data? Of course, we will start to process the incoming data. The data is arriving. We will ingest this data inside the bronze layer. Inside the bronze layer, we ingest the data in a close way to how it is in the source. But it's often that we do some transformations. We define the data types. Sometimes we already define the data types, already ingest as a delta format, and so on. So, even besides the bronze layer, we may need, in some cases, an area to store the incoming data exactly as it arrived. For example, if I'm ingesting from an API, it's a good idea to get the JSON returned by the API and save that file. So I have a perfect image of what I received in one specific execution of the ingestion process. Why do I need that? I need that because if in any moment our end user tells us, well, this data that you are showing me in the resulting report seems strange. Are you sure about what it is, that this is the right data? Then we can track this information back and track this information back to the ingestion execution where we lowered that data. We have the precise image of the data we ingested. So it's good. It's a good idea to have this area. Is this a requirement? No, it's not exactly a requirement. Is this the bronze layer? I would not exactly call this the bronze layer. Some people would call this the bronze layer. I would not exactly call this the bronze layer. In this case, if the first one is the drop zone and the bronze layer is the next one, this one, there is not a specific name, I would say, is an image intended for tracking the lineage of the data. So we store the data exactly how it arrived. And again, you may be noticing that depending on the data source that you use, you may have a higher need of this. For example, if you are loading using API calls, you receive a JSON document, and it's a good idea to store what you received. Or, depending on the scenario, depending on the source, you may have a lower need for this. And an area for the first layer of processing. First layer of processing, where you define data types, you put the delta format. This is the bronze layer. So we are talking about having the drop zone, having a storage to track data lineage in the middle, and having the bronze layer. Is this a requirement? Is this structure a requirement? No, it's optional. It's optional, and you can mix this construction in many different ways in your architecture. But now we know a bit better what we are talking about, and especially the one in the middle, which is a recommendation that I make to store the data exactly in the way it arrived. Sometimes I call it drop zone as well, but the drop zone is more like the place where the file arrives. Here is a lineage storage where I identify the table which was loaded, the time, Sometimes this is the table that which was loaded. Sometimes this is the API which was called. The date and time, and I may have multiple injections in the same day, so I break down these multiple injections using a UID, and then I store the JSONs for these injections for the API calls which were made in this ingestion execution. So I break down the storage by ingestion execution for one specific API in one specific date and save the JSON returned during this ingestion execution. Sometimes, depending on the frequency of your ingestion, you may need to break this even more. You may need to break this by hour, for example. It depends, it varies. So, this is a guidance, not a rule. Some architectures may need these three layers which I'm explaining. Others may need only one of these layers which I'm explaining. Depends, it varies. One, one, one definition that guides if you need it or not is the type of source that you are using. I'm very used on my recent projects with sources coming from API and receiving JSONs and storing the image of these JSONs. So this is the kind of source that I'm very used to in recent projects. Ingestion methods and drop zones, what I'm talking about. I'm talking about a manual ingestion method. Imagine that you do all the ingestion manually. Then you control the shadow. It means that your ingestion, your call to the external source is scheduled. And once you get the data, you control the shadow. When will this data pass to the other layers? When the execution to transform the data to the other layers will be made, you have full control of the shadow. But there are some features that can help in this process. These features we will see today in this session. I'm talking about file arrival triggers. The capability for us to trigger an event when a file arrives. So the technology provides triggers for the shadow. So in this case, we may shadow the first ingestion, the call to outside, get the data, and drop the data in a storage. Then, using file arrival triggers, we can identify the exactly moment when the file arrives and trigger an action to pass this content to the additional layers. So, one, one method, one possible source, and one possible kind of trigger that we can use are triggers related to Azure events. In this case, it's about using the drop zone in an Azure storage account. We use an Azure storage account to create a drop zone. This means that the drop zone will be outside Fabric, will not be inside Fabric. It will be outside Fabric. But you can use file triggers, Azure events, to identify the moment the file arrives and trigger an action for that moment when the file arrives. So we use the real-time hub for that. In the real-time hub, we have the real-time hub, Azure events, and then we have the Azure Blob Storage events. So we can capture events from when file arrives in a blob storage. And it's not only about file arriving, it's about all these events. So in more complex scenarios, we can build even more sophisticated scenarios because you can identify folders creations, blob creation, blob deletion, and so on. In a simple drop zone, which is what I will illustrate today, I will just identify the blob arrival, the blob creation, I will not care too much about the other events. So these are the events that we can capture from the Azure storage, and you can set an alert. What is this button set alert? This is related to the data activator feature in Microsoft Fabric, which was renamed and now is not called data activator, but only activator. Activator feature in Microsoft Fabric. So we can set an alert and we'll be creating an activator object. And this activator object can trigger an action. This activator object can trigger an action from the happening of this event. So when configuring this, when choosing to set an alert, we need to choose the event, we need to choose which blob storage we'll use. And it also asks us to create an event stream. Yes, even if I'm using only the set alert, it asks us to create an event stream because this event, an Azure event, is an external event, is an event from Azure, not a Fabric event. So the event stream is used in this case in a slightly unusual way. The presence of the event stream is used to make what is called streamifying the external event. The external event is streamified to be received inside Microsoft Fabric. Then, while setting the alert, we configure what action we'll make. We'll run a Fabric item. And run a Fabric item could be a notebook or could be a pipeline. We choose the item that we will run. In my example, I'll be running a data pipeline. I created a data pipeline to react to the alert. It's a gap that Microsoft is promising for a long time, and we are waiting this to be created, that we can't pass parameters to the activator object. Sorry, my bad. I explained it wrong. We can't pass parameter from the activator object, which we are creating, to the pipeline. It's not parameterizable. It only calls the pipeline, just that. I can't pass any parameter to the pipeline. This is something that we are missing for a long time and waiting Microsoft to provide us with this feature. So once we make the definition of the alert, we create the object, and the object that we are creating is an activator object. We give a name for the activator object, and this object will be created inside the workspace. Once the object is created, we can open the actual option. This set alert window, as we will notice, are a shortcut to the object creation. Then we can open the object and make some additional definitions if we need to. But in the case of the execution of a Fabric item, there is not much more we can do. As I said, we can't pass parameters to the Fabric pipeline. And as I mentioned, you see the activator object inside the workspace, activator object and the event stream. The activator object and the event stream appear inside the workspace. So let's see how it works. Let's see this in practice working. So what I have here. First, I have a data pipeline easy events. This data pipeline is already built, is intended to read the content of my container, my storage container, and import the content of this storage container to a lakehouse table. So it's opening my data pipeline. I'm making a bit of a defensive development. I check if there is anything in the storage. If there is nothing, I skip. I check if the table already exists to define the import method that I use. Then I make the import from the storage to the lakehouse. This import from the storage to a lakehouse table, this first lakehouse table will be this one, AZ events flights. So this import from the storage to the lakehouse table is like the import to the bronze layer. And then I'm deleting the files. I'm deleting the files from the drop zone. In this scenario, the Azure Blob Storage, the Azure container in the Blob Storage is my drop zone. This is not totally complete. As I explained it would be a good idea to save these files, archive these files to have a perfect image of what we are receiving. So instead of making only a delete files, I should make a move file. Move the file from this container to another place, from the drop zone to an archiving place, and then delete the file from the drop zone. This would be better. But I didn't make it so complete. I'm only dropping at the moment. So I made the first creation of the table, but in this scenario, it's not responding for events in yet. The table is already created. It has a specific set of records. We'll see in a moment. And here in the storage, I have one container AZ events ingestion. This is the one that I use in the first example. So AZ events ingestion, and the table has 250,000 records. Okay. And then I use the real-time hub. I use the real-time hub to make the creation of the Azure event. Azure Blob Storage. I have two options to create the event. I can use the set alert or I can use an event string. Because this event comes from Azure, the event string needs hours to be created. But I can choose to create only the event string and then decide what to do when the event happens. Or I can decide to set an alert, I already set an alert, it will create the event string and the alert. And then I trigger the pipeline from that. So I'm setting an alert, then I'll select the events from, let me specify the workspace, the name of the event string, which I said it will be created as well, not only the alert, but the event string will be created as well. Then I choose my storage table ingestion. Then choosing the storage, I click next. So uh, I can select the events, but all the events are selected by default. If I don't want this to be triggered for all the events, I can select some of them. I can put filters and then click next. Next, review, connect. Okay, connected to my source, which is the Azure Blob Storage. It's creating the event stream and then linking the objects with the event system. Okay. It gives me the option to open the event stream, but I don't want to open the event stream at this moment because what I want to do is to complete the set alert. I'm setting the events for the set alert. Then I'm telling that on each event, I run a fabric item from my workspace, toboggan, and then I select the AZ events, my data pipeline. And I'll save this alert as an activator in my workspace toboggan. So I'll create a new item, an activator, uh, is the files trigger. Let's create. Waiting a minute for the creation. And that's it. My activator is created and I can open the activator. As I said, I can open the activator, but there is not much that I can do inside the activator anymore. I will see what was created, but there is not much else that I can do. It's already configured to execute to trigger the data pipeline. To trigger the data pipeline according the files arrive in the storage. Okay, let me go to the storage here and already cause an event here. Let me upload the file. For files, and I upload this file 01. Okay. Okay, the file is being uploaded. Let's wait a bit. Meanwhile, we can notice what I said. It creates an activator, but it also creates an event stream. The event stream creation is made to streamify the external event. The external event, the Azure Storage event, is streamified to inside Fabric by using this event stream in a bit strange way. A strange way, because anyone who already used real-time ingestion knows that a event stream should have a target. And this event stream doesn't have a target. It doesn't have a target because the only purpose of this event stream is to streamify the external events to inside Azure. There is a very interesting point in relation to this event stream because the amount of combinations that I can demonstrate are only a few, while the amount of possibilities are huge. I'm showing one possibility in relation to the activator. But take a look here. The event stream receives precisely the name of the file which was ingested. The activator doesn't receive the name of the file which was ingested and also can't pass parameters through the data pipeline. So in this way, the data pipeline is developed to work in a generic way. It gets everything there and ingests it. But if I would like to make something more precise, know exactly which file needs to be collected because that file just arrived, I have this information inside the event stream, and I could play a bit more with the target of the event stream. But that's not what I'm doing now. I'm not doing this now. Let's take a look on the Azure storage. Let me make a refresh. Sorry. Uh, worst moment possible to require me an MFA. Yeah, I was connected with this account. I chose the wrong account. Sorry. So the storage, containers, my container is the events ingestion. Um, this is still here, but it will be called, let's say, collected in a few moments. Let's proceed, and this will be, let's say, collected in a few moments. Let's wait a bit. Okay. This is the first example related to Azure events, related to getting files from Azure events using a file trigger and collecting this trigger with an activator. The other example is related to one lake events. The point about one lake events is, what if I would like my drop zone to be inside Fabric as well? What if I would like my drop zone to be inside the files area inside Fabric? Yes, it can be. It can be inside the files area inside Fabric. I can do that. So, how I do that? What if I would like my drop zone to be inside Fabric? In this case, I can use Fabric events, and I can use one lake events. It's interesting that the Azure events, they exist for longer than these one lake events. For a while, it was only possible to make the drop zone, the file trigger with a drop zone in Azure. Then later, the event, the event related to one lake was created. So I can get one lake events and decide about setting only an alert or create an event stream. I use the creation of an event stream. The steps are slightly different. One file trigger. Okay. I select the events and I need to select what is the source in one lake. The source in the one lake is where is the data that I want to identify it arrived. I can choose the lake house and choose the folder drop zone in my lake house. In this case, I will identify the arrival of files in the drop zone inside my lakehouse. It's already showing here that I'm selecting files from the drop zone in this lakehouse. I could set filters or not set filters. Then next and connect. It's creating the event string. While it's creating the event string, we can take a look on the Azure Storage. It's taking longer than I was expecting. I'll check this in a moment. Okay, so it's creating the file trigger. We can take a look on the activator. By looking at the activator, this is the Azure activator. I can note when an event arrived and when the condition was met and the event was triggered. This event was triggered. So 12:35 GMT, 12:28, 12:35. The activator sometimes creates a delay on the trigger of the event. Then I can take a look on the recent runs of the pipeline. This is not GMT, so it's not doesn't have an execution yet, but you have in some moments. Okay. Back, it created my event stream. Let me finish. Let me open another window here. So now I have the second event string intended to capture the events related to the one lake, one file trigger. This event string is created, but this event string now it needs a target. In the one lake, for one lake events, they are not external events, they are fabric events. Here I need to define a target. If I had selected the option to use alert, only the alert would be created, not the event string, only the alert, because these are internal to Fabric, they are not external. And here on this event string, I'll define an activator as target. Uh, File trigger activator, I'll create a new activator, one file trigger. This activator is not configured yet. Yes, it's not configured yet. We set the activator in the event string, and then we complete the configuration of the activator in the following steps. Let me publish. Okay. So it's basically turning on the objects. Basically, that's what we made there. Let me just duplicate this tab, but let me refresh. And I can already see the activator here, one file trigger. So I can open this activator, one file trigger. The activator is receiving events from the event string, it's from the string, but it doesn't have anything. It doesn't have a rule or an action. So I'll define a rule, a new rule, and this new rule defines that the action should be executed for every value arriving. It calls value when it comes from the event string. For every value, it will execute this, and it will execute what? It will execute a data pipeline. For every value, it will execute a Fabric data pipeline, and I'll choose the one event is a different pipeline. Yes, I have two folders, one to receive data from Azure, from the drop zone in Azure, and the other to receive data from the drop zone in Fabric. Here you see two tables that I have, one to receive data from Azure, one to receive data from Fabric itself. So the activator is defined. I will change to view. Changing to view is a way to set it live. Okay, it's live here. Then in the one lake, in the lake house in this case, I have the drop zone area. I can upload the file in this drop zone area. Is an option to upload the file here. Another option which I have as well is to use the One Lake Explorer. I can use the One Lake Explorer to navigate on my Fabric objects. I use the One Lake Explorer to navigate in my Fabric objects and to insert files from my in my drop zone. I can drop files here using the One Lake Explorer. So I just drop out a file here. The activator will be triggered in a while. Let's check the first one again. Um, is the curse of demonstrations. We make everything right before the demonstrations and something goes wrong during the demonstrations. Let me check the recent ones. So it doesn't have a recent one of the Azure events. I'll check in a moment what happened. So we have two file drop events which I'm capturing with these steps. I'm capturing the file events from the Azure storage, and I'm capturing the file events from the lakehouse. From the lakehouse, I'm receiving the file events as well. So in this way, we are seeing two methods to make the capture of the file events. Uh, Two methods for two different locations for Azure storage and for One Lake. There is a third method. There is a third method which is called continuous ingestion. This method was announced on the last build. It's a very interesting method that allows us to make a continuous ingestion from Azure storage to a custom database. That's why I have a custom database here, exactly to prepare for the continuous ingestion process. But the authentication for the continuous ingestion process is also slightly different. We need to make a special authentication method. In fact, I love that this new feature, the continuous ingestion, pushed forward the workspace identity authentication method. I not only create a workspace identity, but now I can authenticate with the workspace identity in face of Azure storage. I can use the workspace identity to authenticate in face of Azure storage. The workspace identity is the only authentication method allowed in continuous ingestion. Continuous ingestion only allow the workspace identity. So I need to go to Azure and I need to include this workspace identity in a group of admins. Power BI admins, members, add members, and we have here the toboggan. Toboggan is the workspace identity which was just created from inside Fabric. Select. Okay. So I defined the permissions for this workspace identity, and then I can proceed with the continuous ingestion. Unfortunately, I'm exactly on time. So let me show fast how it would be done. On Custo, we use get data, and when making the get data for an Azure storage, in the get data we select here Azure storage. When making the get data for Azure storage, we have this new selection, continuous ingestion. This new selection to define the continuous ingestion from the Azure storage, I define the table, the target table. Inside custom, the target needs to be custom. and the authentication will be using workspace identity. The environment, Fabric environment, will authenticate using workspace identity. Let me review the storage I have, but it seems that the curse of demonstrations is hitting me. Let's see the first one. Yes. The terrible curse of demonstrations is hitting me harder this time. I tested everything before the session, and now the events are not being immediately triggered. Um, so I'm very sorry for that. I'm very sorry for that. It seems that I was caught by the curse of the demonstration, but the steps are exactly these, with some variations that we notice. So what we talked about? We talked about what's a drop zone, the file drop event from Azure Storage, which we can capture uh, in an alert and in an event stream. The file drop event from one lake, which we can capture in alert or in event streams, and the continuous ingestion, which can be done only to inside custody and use the workspace identity. I have some videos, some isolated videos in my YouTube channel, which show these examples actually completing in my YouTube channel. For now, it seems the activators are at least a bit delayed. I will confirm later in a message on my LinkedIn how long it took for them to actually execute the action.
Dennis, sorry, sorry, I'm gonna have to stop you there because we got a tight
Yes,
turnover for this.
yes.
Thank you. If could I ask then if you can share in the chat what you mentioned a YouTube channel,
Oh,
or
yes,
at least a
yes,
thing,
sure,
yeah. Um,
sure.
sure, but yeah, thank you very much for the talk. It was really insightful. I am gonna have to very hastily move across to Rajesh. Sorry, so. Yeah, if there's any questions, please put them in the chat, and hopefully Dennis can
I'll be here following the
respond to
chat.
them.
I can answer any questions on the chat.
Yeah.
Thank you very
Okay.
much. Thank you very much, Justin. Thank you very much, Andy. Thank you for inviting me to deliver the session. Thank you.